Hello, this is John from caveofprogramming.com, and this is tutorial number 5 in the series of advanced Java tutorials on multi-threading from Cave of Programming. Now in this tutorial we are going to look at thread pools, and thread pools are a way of managing lots of threads at the same time. So let's say we've got a processor class here which implements the runnable interface as usual. So I'll say public void run, and in here this run method from the runnable interface, I will put some code that I want to run. But actually what I'm also going to do is, because I'm going to fire off lots of these processors at the same time, I will have a constructor that accepts an ID so that I can tell which one's which. I will say private int ID, and I'll set the ID here so I can pass in the ID when I create the processor. Equals ID. Well, now in here, when processing starts, I'm gonna output a message saying starting and the ID, and when my processing finishes I will output a message saying completed ID. And in the middle here I'm going to simulate doing some useful work, like for example handling requests if this is a server, or perhaps processing files or whatever. And as usual I use the handy thread.sleep method to sleep for 5,000 milliseconds, 5 seconds. So now I could, if I want to, let's say I want to create 10 of these processors and make them work through 10 different tasks, I could use the thread class as usual, but instead I'm going to use executor service. I'll call this executor, and I'll use a static method of the executors class called new fixed thread pool to create 2 threads, and I'll do Ctrl+Shift+O in Eclipse to add the missing inputs up here. Now, so what is a thread pool? A thread pool is like having a number of workers in a factory, in this case 2 of them, and you've got a load of tasks that you want them to get through. For example, in this case we'll say there are 5 tasks, and I want each of these workers, threads in other words, to process a task, and when this worker thread finishes processing a task, I want it to start on a new task. So it's like giving my 2 factory workers a bunch of tasks and saying, here, please work on these tasks one at a time, and when you finish one task, start on a new task. And of course usually this would be, it could be probably be a lot higher than 2. You might have 10 or 100 or whatever threads running at a given time, and you might want to get through, who knows, thousands of tasks. So to allot the tasks here, I want to submit tasks to executor. The executor service will run its own managerial thread that will handle parceling out these tasks that I'm going to give to it, and I want to submit a bunch of tasks to it. So I'll give it 5 tasks in this example. I'll say I goes from 0 to 4 here, and I'll say executor.submit to submit a task, and I'll say new processor, and I'll give the processor an ID just using my loop variable here. And then as I say, executor service has its own special managerial thread, and I want to tell that thread after this point to stop accepting new tasks and to shut itself down when all the tasks have finished. So I will say executor dot shut down, and this will not shut down immediately, but it will wait. It will wait for all the threads to complete doing what they're doing, and then they will terminate. And just to show you that all this stuff returns immediately, I'm going to do a sysout, and I'm going to say all tasks submitted. And now let's suppose I want to wait for all the tasks to actually complete, all 5 tasks. What I can do is I can say executor.await termination, and here I give it I specify the time that I want it to wait for. I'll say 1 in this case, and this is the unit of time that this refers to. So I'll say time unit dot days in this case. So in this case, I've got I'm saying wait for 1 day, and effectively, of course, I've got no timeout at all here, which is what I want. But supposing you put, for example, 10 seconds in here, and you had this was seconds and this was 10, and supposing your tasks didn't finish in 10 seconds, this would wait only 10 seconds, and after that it would return. But and so you could execute more stuff down here. But because I'm saying 1 day here, basically this is going to wait until all my tasks have finished. Now this throws an exception, and I'm going to surround that with try catch, and here I'm going to say sysout all tasks completed. Okay, so let's run that and you'll see what happens. So I click run and it says all tasks submitted, and that happens immediately. And then it starts the first task and the second task. This is actually task 0 and task 1, but basically all this stuff is happening at basically the same time. And then when one of the tasks completes, which happens to be a task with the ID 1, it will start a new task in that same thread, because the thread is now not doing anything. The worker in my factory is idle, so to speak, and he's getting a new task assigned to him. So it's starting a new processor here. And then eventually task 0 also completes, and thread is given a new task, and it works through all 5 tasks like this. We've got 5 tasks, and the 2 threads are processing the tasks, and one thread will do 1 task at a time. But as soon as one thread has finished and it's idle, that same thread will now process a new task. And the advantage of that is that there's a lot of overhead to starting threads, and by recycling the threads in this thread pool, you avoid that overhead. Okay, so that's all for this tutorial, and I hope you'll join me again next time. You can find this code and other information and tutorials on caveofprogramming.com. And until next time, happy coding.